Welcome back, friends, to our AlphaTeX Aptitude Series. If you haven't really checked out our previous videos on Aptitude Series, we'll leave the links in the description as well as in the end screen. Do make sure to check them out, and we hope that it'll really help you. Our today's topic is divisibility, where we will check whether a given number is divisible by another number or not. Now, our first one is going to be divisibility of 2. For a number to be divisible by 2, the last digit of the number whose divisibility we are checking must either be an even number or a 0. Once again, if the number is to be divisible by 2, then the last digit of the number must either be an even number or it must be a 0. Now let's check out some examples. Like we have here 356, where the last digit is an even number. So it is obviously divisible by 2. Again, 890, where 0 is the last digit. So as we have the condition, the last digit has to either be an even number or a 0, and then only is divisible by 2. So here we have that the last digit is 0, so it's divisible by 2. Here again, the last digit is 4, so it's also divisible by 2. Now let's move on to divisibility of 3. Now, a number is divisible by 3 only when the sum of its digits is divisible by 3. Therefore, 372 will check whether it is divisible by 3 or not. Now, if the digits of 372, that is 3 plus 7 plus 2, that makes 12, it is obviously divisible by 3. Therefore, 372, it is divisible by 3. Now, let's check for 456. 456 is going to be 4 plus 5 plus 6, that's going to be 15. Therefore, 15 again is divisible by 3. Therefore, 456 is also divisible by 3. Now, how do we find that out? We see here that 372 has 3 digits. Therefore, we add up their digits individually. That is 3 plus 7 plus 2. The number that you get in result is 12. If that number is divisible by 3, then this number is obviously divisible by 3. Now, that's the rule for the divisibility of 3. Let's check out for divisibility of 4. Now, for divisibility of 4, a number is divisible by 4 only when the last two digits of the number are divisible by 4. Here, taking 64 as example, we can see that the last two digits are the number itself, that's 64. So if you divide 64 by 4, what you get is 16. Hence, 64 is divisible by 4 as the last two digits are divisible by 4. Now, taking 144 as example, the last two digits are 44. So 44 is divisible by 4, hence 144 is also divisible by 4. Now, taking 156 as example, that's 156. Taking the last two digits, we get 56. It is also divisible by 4, hence 156 is also divisible by 4. Therefore, now let's check out divisibility of 5. Now, for divisibility of 5, a number is divisible by 5 if the last digit of the number is either a 5 or a 0. Here we can check, taking 255 as example, that the last digit being 5, therefore it is divisible by 5. Again here, taking 490 as example, the last digit is 0, therefore it is divisible by 5. Taking this huge number as example, we can check that the last digit being 5, it is also divisible by 5. Hence it's really easy to check the divisibility of 5. Now let's go and check the divisibility of 6. Now for the divisibility of 6, a number is divisible by 6 if the last digit of the number is even and the sum of the digits is divisible by 3, which is actually the divisibility of 2 and 3 combined. As divisibility of 2 was, a number is divisible by 2 if and only if the last digit is divisible or it is even, and the divisibility of 3 was that the sum of the digits must be divisible by 3. Therefore, divisibility of 6 is actually divisibility of 2 and 3 combined. In this way, we can also find out divisibility of like 26, as it would be divisibility of 13 and 2 combined, right? We can also find out divisibility of 18 as it would be divisibility of 2 and 9 combined, right? Similarly, divisibility of 6 is divisibility of 2 and 3 combined. Now let's check out some examples. Our first example is 36, and here the last digit is even and the sum of the digits is going to be 9. Therefore, it is divisible by 6 as it is divisible by both 2 and 3. Now checking 144, the last digit is even and the sum of the digits is again 9, therefore it is also divisible by 6. Now let's check out divisibility of 8. We'll not do divisibility of 7 as it is a bit complex and it has multiple methods to check for divisibility. Therefore we'll jump directly to divisibility of 8. Now let's check it out. Now checking divisibility of 8. A number is divisible by 8 if the last three digits of the number are divisible by 8. So here we can check this huge number, that's 2, 3, 4, 1, 2, 5, 6. Let's check if it is divisible by 8. Now 256 is divisible by 8. Therefore, this entire number is divisible by 8. You can check it through your calculators. Now, taking the second number as example, that is 74098056, we again check if it is divisible by 8 or not. For that, we select the last three digits that form the number, that is 056, which is actually 56. Now 56 is divisible by 8, therefore this entire number is divisible by 8. It's that easy to check. Now let's check out divisibility of 9. Now for divisibility of 9, our number is divisible by 9 if the sum of the digits is divisible by 9. Here, taking 63 as example, we can see that now the sum of the digits are going to be 6 plus 3, that is going to be 9. Therefore, this is divisible by 9, hence 63 obviously is divisible by 9. Taking a second number, that's 549 as example, we can see that 5 plus 4 plus 9, that's going to be 18. It is divisible by 9, therefore 549 is divisible by 9. Now, we need not check divisibility of 10, obviously, because as we know, if the number ends with a 0 or the last digit of a number is 0, it's obviously divisible by 10. Now, we'll jump directly to divisibility of 11. Now for the divisibility of 11, a number is divisible by 11 if the difference between the sum of the digits at the even places and the sum of the digits at the odd places is either 11 or 0. So when you add digits at the even places, that is like this and this, these are even places, as the positions are, if you mark them as 1, 2, 3, 4, this is the second position, this is the fourth position, both of them are even positions. So if you add numbers at the even positions and you add numbers at the odd positions and then you find out the difference between these two, then if the result is either an 11 or a 0, then that number is divisible by 11. So if you find out the sum of digits at the even positions and the sum of the digits at the odd positions and you find out their difference, then if the result is either an 11 or a 0, then that number is divisible by 11. So here 1331, the sum of the digits at the even places is going to be 3 plus 1, that's 4, and for the odd places it's going to be 1 plus 3, that's again 4. So 4 minus 4 gives us a 0, therefore it is divisible by 11. Now 58432, that's our second example. Now taking its digits, let's mark the positions 1, 2, 3, 4, 5. Now let's add the digits at the even places, that's going to be 8 plus 3, that's going to be 11. And again, adding the digits at the odd positions, that's 5, 4 and 2. So 5 plus 4 plus 2, that's also 11. So 11 minus 11 is again 0. Therefore, this number is also divisible by 11. That way you can check divisibility of 11. Now, as I had said earlier, if you want to check divisibility of large numbers like 22, you will have to check for divisibility of 11 and 2, as 22 is essentially 11 into 2. Therefore, if you want to check divisibility of greater numbers, try to make them or try to form them as combinations of the numbers whose divisibility we have already checked out. Now, if you really like this video, then do give it a thumbs up and don't forget to comment out your suggestions. Do subscribe to our channel if you already haven't, and stay tuned for our upcoming videos. Thank you for watching.